Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss Stern-Gerlach experiment. Let's begin. In previous video lectures, we have discussed regarding space quantization, electron spin and vector atom model. All these things are well explained throughout that of Stern-Gerlach experiment. What is the objectives of that of Stern-Gerlach experiment? When an atom passes through an external magnetic field, then the orientation of atoms, the orientations of atoms are quantized. Quantized means we get discrete stresses. To perform that experiment, Stern and Gerlach prefer one oven, two slits, pole magnets that is specially designed, photographic plates, What is the arrangement? Taking this as the oven, this is the oven in which the silver atom, in that of oven we take silver atom in ground state, and the collimated beams of silver atom are emitted from this hole, and these collimated beams are passes through two slits, these are the slits, and we take two pole magnets specially designed to produce non-uniform magnetic field. This is the south pole, that is the north pole of that of magnet, and that beam passes through that pole magnets. These are pole magnets specially designed to produce non-uniform magnetic field, and a photographic plate is here. This is the plate, photographic plate, where we have to observe the traces we found two traces. Look here, why we choose the non uniform magnetic field for Stern-Gerlach experiment to perform. We designed the magnets as the designed magnets. This is the cross sectional view of that of magnets, pole magnets. How the non uniform field is created. This is the south pole, that is the north pole. The magnetic lines are traveling from this. These are the magnetic lines, means the magnetic field strength. The magnetic field strength is more in that of north pole region as compared region to that of south pole region, and the magnetic lines are along that of z direction. We take, this is x direction in which the atoms are propagated. This is the xy plane, and here the direction of that of magnetic field along z direction. Why we choose the non uniform magnetic field for Stern-Gerlach experiment? Because when a magnetic dipole is placed in a uniform magnetic field, when a magnetic dipole is placed in a uniform magnetic field, it experiences a torque. It experiences a torque, means that magnetic dipole rotates, but there is no such tracing forces. There is no such tracing forces, but here it is necessary to that of tracing forces as the magnetic field throughout that of z direction. To avoid this, we prefer non-uniform magnetic field. To avoid this, we prefer non-uniform magnetic field, and to create that non-uniform magnetic field, we take that type of arrangements of the special type of magnets. Again, a question arises, why we take the silver atom in ground state, not in ionic state or in that of excited state? Because when we prefer the silver atom in excited state or the ionic state, when that ion passes through that of magnetic field, it experiences a new type of force, that is Lorentz force, and due to that Lorentz force there will be no production of tracing forces. That means the Stern-Gerlach experiment is not important, is not determine that type of events. Means since there will be no such tracing force, there will be no magnetic field inside that of z direction. Therefore, the silver atom in ground state, and the experimental magnetic field is non-uniform. These 2 points are important here. Here we take 2 points. One is non-uniform magnetic field, and another one is the silver atom in ground state. Silver atom in ground state. These two are most important for this type of experiment, non-uniform magnetic field and the atom is in ground state. Now, what is the observations. When the silver atoms are passes through that of slit and along that of non-uniform magnetic field, there are two traces observed in that of photographic plate. But actually, if we think, when that silver atoms are passes through this, there will be various types of orientations. Look here, let I take here as the oven, the atoms are generated from that of oven, and the orientation looking like in that direction, some atoms are this direction, that direction, this. There are various types of orientations are found, and when we observe in that of photographic plate, that means there are so many traces are observed throughout that of photographic plate, and the traces, here is the traces, here is the traces, here is the traces. But actually there are only two traces observed inside that of photographic plate. Why? That happened? And these traces, there are no such traces in the middle, and the trace points are equidistant from that of middle point, means the traces are symmetric. Why? To explain this experiment, we prefer two ways. One is qualitative discussion and another one is quantitative description. First, qualitative one, qualitative description, qualitative explanation, qualitative description. What happened actually? The atoms passes through that magnetic field the atoms passes through that of magnetic field were oriented in a discrete angle, so that the deflected beam, deflected in certain discrete direction and gave discrete stresses. Throughout that of photographic plate, means the orientations of atoms are two ways. As a result, there are two traces are found out throughout that of photographic plate. Let us define it quantitatively. Why two traces are found out and why these two traces are symmetric in nature, and there will be no such traces in that of middle point. Okay, let us discuss it. The qualitative, here it is the qualitative description. Now the quantitative description. Quantitative description. Quantitative description. Okay, let's. Here the magnetic moment is mu. Here the magnetic moment, total magnetic moment, that is mu, and magnetic field strength, magnetic field strength, magnetic field be B vector, and the potential energy, potential energy, let V, let U, potential energy U as the negative of dot product of B dot mu. This is the potential energy, and therefore the force is the negative gradient of that of potential energy, that is negative grad U, which is equal to minus grad, in place of potential energy substitute minus B dot mu. This is the classical one as we discussed here, that is grad of B dot mu, and the z component of that of force, that is the force F, that is the force F. So the z component of force, z component of force, that is F of z, is equal to its z component means del Bz by del z mu j z. Mu j is the total magnetic moment along that of z direction, along that of z direction, mu jj, that is the total magnetic moment of z component. What are the terms? Fz is the z component of that of force, and del Bz by del z, that is the rate of change of magnetic field, rate of change of magnetic field along z direction, and mu jj, just I write here, that is del Bz by del z is the rate of change, that is the rate of change of magnetic field, rate of change of magnetic field along z direction, along z direction, and mu jj, that is the total magnetic moment, that is the total magnetic moment along z direction, total magnetic moment along z direction, or total magnetic moment of z component. Okay, as we consider along z direction only, there will be no such component of x and y, that is the z component. Okay, now what is mu j? Mu j, that is Gj E by 2m to j. These are discussed earlier. Now the z component of mu jz, that is Gj E by 2m, z component of j, and the z component of j, here jz, that is the mj h cross, means mj h by 2 pi, mu j mj h by 2 pi, mj is the inner quantum number. Let putting these values in the z component of that of force, we take it as equation number 1. Now putting these values in equation 1, therefore we get, therefore f z is equal to del bz by del z. In place of mu jz we substitute gz e by 2m jz. The value of jz again putted, that is mj h by mj h by 2 pi. mj h by 2 pi. Okay. Here we put the value of jj, value of jj when we put here, that is gj e by 2m into the value of zj, that is mj h by 2 pi, means it will be what, that is gj e h divided by 4 pi m mj, and that term is known as Bohr magneton, that is the Bohr magneton term. Therefore that is gj, that is mu b mj, that term is the Bohr magneton term, Bohr magneton. Okay, what we get, gj mu b mj del b by del bz del z gj mu b mz, that is mu b mj. Okay, that is equation number 2. Here is the equation number 1, here is the equation number 2. Since a force is applied along that of z direction to that of atom, then an acceleration is produced according to the Newton's law of motion. So the acceleration along that of z direction, the acceleration along that of z direction, that is the force divided by mass, force divided by mass. Let mass of atom be capital M, mass of atom be capital M, that means 1 by m, the force term, that is del bz by del z gj mu b mj, that is equation number 3. Now if where m is the mass of atom, mass of atom, if v of y is the longitudinal velocity, longitudinal velocity. Looking here, This is the velocity in that of longitudinal direction, and the displacement in that of transverse direction. So, Vy taking as the longitudinal velocity, Vy taking as the longitudinal velocity, and d is the distance travelled in that of magnetic field by that of atom. The distance travelled in the magnetic field by atom, and t is the time taken by the atom to cover the distance d, So, the velocity Vy is equal to, that is distance by time, which implies time taken will be d by Vy. That equation number 4. Vy. Now, from kinetic theory of gases, from kinetic theory of gases, the kinetic energy of that of gases, that is half m Vy square, that is the kinetic energy, is same as 3 by 2 kT. K is the Boltzmann constant, where K, that is Boltzmann's constant, and capital T be the temperature in Kelvin. Here putting the values, half cancel out. So, Vy square is equal to 3 kT divided by m, which implies Vy is the under root of 3 kT by m. Now, what is the value of Vy? Again Vy is same as d by t. Just putting here d by t means the value of Vy, that is 3 kT by m under root is equal to d by t. So, time taken t will be d times of under root of 3 kT by m, that is the time period t. Okay. Now, if the transverse deflection means the transverse deflection be z, that is the transverse deflection in that of z direction. So, the transverse deflection be z, then what happened here? The transverse deflection z is equal to, we use Newton's equation of motion, the distance travelled by a body is given as S is equal to ut plus half at square. U the initial velocity, but here in that of transfer section in z component there will be no such term of initial velocity, means the initial velocity is 0, that is ut plus half at square. So you use half acceleration along z direction az and t square, putting the values half the acceleration term, the value of acceleration of z component, that is the acceleration term, means a by 1 by m, put here 1 by m del bz by del z gj mu b mj and t square, square of t, that is d square and 3 kt divided by m, 3 kt. Okay, when we change the position it will be t by, that is m by 3 kt, in that of bracket it will be m by 3 kt under root of, that is m by 3 kt, m divided by 3 kt. So mm cancel out, separating this we write gj mj del bz by del z mu b d square divided by 3 into 2, that is 6 kt, 6 kt. The value of gj and mj, that term is a constant one, is a constant, and here gj is equal to 2 and mj varies from minus j to plus j, minus j to plus j, and the allowed values are 2j plus 1, the allowed values are 2j plus 1. Now in case of ground state silver atom, ground state we consider in that of oven as ground state silver atom, ground state silver atom designated as the multiplicity is 2 s half. This is the ground state silver atom. From this we conclude that is the spin quantum number is half, that is the j, transfer that is spin quantum number, spin quantum number is half, and L, since it will be S state, the L will be 0, and that term is the j, total angular momentum, total, that is the j is the quantum number, inner quantum number is the half. So mj, the allowed values are minus j to plus j, means here mj varies minus half to plus half, mj varies from minus half to plus half, and the allowed values are 2j plus 1, means 2 into half plus 1, that is 2 values, one is minus half and another one is plus half. So the values are minus half and plus half. Let us using this mj here gj is equal to 2, gj is equal to 2, therefore the term gj mj, gj 2 into minus half we get minus 1, and again 2 into plus half we get plus 1, one is minus 1, another one is plus 1, that means we get plus minus 1, plus minus 1 we get the value of Gj and Mj term. So, putting that value in that of transverse reflection, that of transverse deflection. What is that of transverse deflection? So, therefore, transverse deflection Z. Here the transverse deflection is plus minus that factor del Bz by del Z mu b d square divided by 6 kt divided by 6 kt, means the allowed values is 2, one is minus half and another one is plus half, and the discrete traces will be plus minus this much. So, quantitatively we get two values, one is plus half, that means the upper half and the lower half. This is the transverse direction. In that point we get one trace, in that point we get another trace, two traces are found out. So, qualitatively and quantitatively we get the result. This is the two discrete values are found out here. So, with the help of this video lecture we understand what is Stern-Gerlach experiment. This is the Stern-Gerlach experiment. That one is the objectives of that of Stern-Gerlach experiment, and this is the experimental setup. This is the experimental setup, and we explain it in terms of qualitative description and in terms of quantitative description. Why the traces are found out discretely, or the orientation of that of atom is quantized, the quantitative description. Two values, since it will be plus minus. So, with this useful and informative notes, let me wind up this session. Thank you.